So our
yes,
topic
sir.
of interest is first is statement of Newton's law. Then we will discuss frame of reference. Then constraint relation. Then system. Clear? So first we will start our
Okay, sir.
Newton's law. So write down Newton's first law. Newton's first law. Write down the statement first. It states
Okay, sir.
that acceleration of body is zero until and unless an external force
Yes, sir.
act on it. Clear? First law. First law. Define the concept of force. Clear?
Okay,
What
sir.
according to first law, what is force? Force is a physical quantity. Physical quantity which accelerate the body. Which accelerate the body or an object. Clear?
Yes, sir.
Understood? What is the meaning
Yes.
of Newton's first law? So Newton's first law actually it gives the qualitative discussion of force. It does not tell us how to find the force. A body is at rest, always wanted to be in rest. A body in motion always try to be in motion. That is inertia, law of inertia. So first law is also known as law of inertia. Inertia, I think you are well familiar with the inertia. Clear?
Yes.
First law simply give the definition of force or concept of force. Moving to the next law, that is Newton's second law. Clear? Newton's second law. So whatever you are speaking yesterday, like momentum change, everything I will discuss. Everything I will discuss. Don't need to worry. So Newton's second law
Okay.
actually gives us the quantitative discussion. Means it tells us how to find that force. Clear? It tells us how to
Yes.
find the acceleration of an object. So who give the definition of acceleration? Newton's second law. So you can write. It states that that force acting on a body, clear, is F net. Then acceleration is equal to net force divided by mass. Clear?
Okay, sir.
Let us understand this. I think this is yesterday I have explained, but I will explain again. Let's see. For example, this is an object. Here, and on this object, many forces are going to act. F1, clear? F2, F3, clear?
Okay, sir.
And this object is having the mass M. So what is the net force? F net, F1 plus F2 plus F3. Clear? So acceleration, there is a net force, there is a acceleration. Acceleration will be net force divided by mass. Clear?
Okay, sir.
Understood?
Yes, sir.
M is the mass of an object on which our force is going to act. That force. Moving to the third law. Write down. What is third law?
Sir, acceleration is proportional, sir.
Acceleration is proportional to force and inversely to the mass. Clear?
Can you please put the slide, sir? Again, I am writing.
You should write.
Okay.
Please write. Have you written?
Yes, sir.
Now write down Newton's third law. Write down. It states that if a body A apply a force on body B, then simultaneously you can write the body apply a force F1. It is in vector, okay? F1,
Oh,
F you can write. It is in vector, clear? On body
yes.
B. Then simultaneously body B, body B body B apply the force minus F on body A. Okay?
Yes, sir.
Meaning is what? Have you written this?
Sir, no, sir, writing, sir.
Please write. It's very important.
Yes, sir, completed, sir.
Okay. See, look at this diagram. Till first law clear, the second law is clear, third law.
Mm,
Third law I will explain. For example, this is our earth. Clear?
okay.
And on this earth, one block is placed like this. This block is having the mass at clear. This body is A, clear, and this body is B. Understood?
Okay, sir.
Now, let us suppose this earth is having the center here. Then earth is applying which force on this body? Gravitation force. That is clear.
Yes, sir.
Clear. If earth is
Yes,
applying mg force on body B, then body B is also applying mg on earth. Like this. That is action reaction. This is action. Clear. And this is reaction. For every action, there is equal and opposite reaction, but bodies must be different. If A body apply a force on B body, then B body is also applying a force on A body. So one more example. Let us suppose this is the ground, okay? On this ground, I just place a block. This block is, let us suppose body B, and this floor is body A. Clear?
okay.
Then the floor will provide the repulsion force, that is normal reaction force, upward direction. Let us suppose N1. Clear? Then this block is also applying N1 force on the floor, but direction is opposite. Similar force. This is action. This is reaction. Clear?
Okay, sir.
So for every action, there is equal and opposite reaction. If body A is going to apply force on body B, then body B is going to apply force on body A. But the condition is a single body can't apply action reaction on itself. Can't. It is not possible. There must be two
Okay.
different bodies. Clear? A and B.
Okay.
There must be two different bodies. After this, write down the concept of frame of reference. Write down. Write down. Adding before understanding the frame of reference, write down the unit, not unit, topic, rest. What is rest? Clear? Write down. Rest means position does not change with time and space. Space means surrounding. Clear? Is it clear to you? Motion means position does change with time and space. Now what is space? Clear?
Okay, sir.
Now what is space? इसी space को हमें क्या समझना है? Clear? ये space क्या होता है? ये frame of reference होता है. Clear? ये space ही क्या होता है? Frame of reference. So write down what is frame of reference. Write down the heading. Reference. Clear?
Yes, sir.
Write down what is frame of reference. Write down. Frame of reference means frame of reference is the name of an observer. Clear? Frame of reference means it is the name of an observer. Clear?
Okay, sir.
After this, write down if frame is not given. If frame is not given, then assume observer is standing on the ground. Clear?
Okay.
Is it clear to you?
Yes, sir.
Okay. So frame means simply it is the name of an observer. Clear? If frame is not given, then assume observer is standing on the ground. Clear?
Okay.
Now I will explain this with the help of one example. Clear? See. See. For example, this is a moving train. Clear? In this moving train, clear? Observer one more observer is here. Clear? And there is one more observer that is standing on the platform. Clear? Clear? A, B, C. Clear? ये क्या है?
Yes.
Moving train 60 किलोमीटर पर आवर. Clear? And this is the platform. Okay? Clear?
Yes, sir.
So meaning is what? There are two persons A and B. They are the passenger who is in the train, and train is going at a 60 kilometer per hour. And person C is standing on the platform. Clear? And this platform is at rest. Clear? Okay. So my question is, if I ask you, as per observer C, what is the condition of A? As per observer C, what is the condition of A? A is at rest or in motion? Tell me. Tell me. If I ask you,
Sir, are you? Yes, sir. With
you just
respect
tell,
to
you just tell me if observer C is looking A. Clear?
Okay.
If observer C is looking A, then according to C, what is the condition of A? Is it at rest or in motion?
Motion, sir.
Motion. So what is the, how should I write? A is in motion. Clear? A is in motion as per C. But if I ask, as A is in motion according to C. Clear? Now if I ask you, what is the state of A as per B? Tell me. It is at what? What?
Motion of A according to B.
A is in rest, okay? According to B. Why? Because have you seen like when you are moving in a train, clear? When you are moving in a train, then all the passengers in a train are at rest. Clear?
Okay.
Understood? So when
Yes,
you are
sir.
moving in a train, then inside a train, then all the passengers are at rest. Clear?
Okay, sir.
Understood?
Yes, sir.
Then why the same object is in motion, the same object is in rest? What is the reason like? My question.
Frame of reference is sir.
Yes, yes. Frame of reference. So we will learn the frame of reference now. So what is frame of reference? It is the name of an observer. Clear? Frame of reference is the name of an observer. If frame is not given, then assume observer is standing on the ground. Clear? Understood? If frame of reference is not given, always take observer is standing on the ground. So frame of reference is the basically name of an observer, or it is the name of place where observer is present. There, understood?
Yes, sir.
It is the location where observer is present. Either you can say it is the name of an observer, or you can say it is the name of the location where an observer is present. Okay. Now you
Okay.
please tell me, if I say observer is C, then I can say this observer frame is platform. Here observer means C. C is located where? C is in the on the platform. So platform is the frame of reference. Understood? For A and B, our frame is moving train. Clear? A and B. For A and B, frame is moving train. Clear? Moving train. Understood?
Yes,
For
sir.
C, frame is platform. Clear? Okay.
Okay.
So frame of reference means it is the location where an observer is present. Clear? I
Okay.
think this is clear to you. Now
Yes,
write
sir.
some points. That is why like the same object is in motion, same object is in rest. Now one thing like rest means position does not change with time and surrounding. Surrounding means frame of reference. Clear? Understood?
Okay.
Now write some points. Write down. Write down. One. One. Okay.
Okay, sir.
Now write some points. Right. Right. If the velocity of if the velocities of two observers are same in magnitude and direction, then their frame of reference becomes equal. Clear? So if the velocity of two observers are same in magnitude and direction, then we can say their frame is equal. Clear? Understood? In
Yes,
previous
sir.
example, have you seen like in this example for A and B? For A and B, they have same frame, moving train. Why? Because train is moving with 60 km per hour, then A and B are also moving with 60 km per hour. then they have same frame.
Okay.
Here, for A also
Yes, sir.
same frame, for B also same frame, because they are in the same train, they are also moving with the same velocity. The velocity of two observer. Here, if I ask you one question, for example, as per A, clear? As per A, what is the condition of C? Motion, clear? As per, according to A, clear? And according to B also, C is in motion, clear?
Okay, sir.
Clear?
Yes, sir.
Why? Because for A and B, if A and B are two observer, for both of them, clear? They have same velocity. Clear? Velocity means same magnitude and direction. That is why their frame of reference are equal. For both A and B, their frame is what? Moving frame. That is why they are giving same answer. Understood?
Yes, sir.
Okay. Now after this, write down next point. Force, mass, and time does not depends on frame of reference. Very important. Frame of, okay. These points are very, very important. After this, write down types of frame. Clear? Types of frame. Types of frame. First is inertial frame. What is inertial frame? Write down. Write down. It is a frame in which Newton's law of motion are valid / applicable. Clear?
Okay.
By an experiment, Earth is an approximate inertial frame. Clear? If we neglect rotation and revolution of Earth, clear? What is the meaning of this? See, we all are living on the Earth, on the surface of the Earth. Clear?
Yes, sir.
And Earth is a, why we are considering Earth is at inertial plane? Inertial means simply at rest. Why we are considering Earth is at rest? Because the rotation and revolution, clear, of the Earth is very, very small. Clear? That is why
Okay.
because we are also living on the Earth. Clear? And if you find out the rotational speed of the Earth, it is very, very small. We can neglect. So we can consider Earth to be as inertial frame. That is ground. Clear? For example, I think you are familiar or not. Maybe later on when I am explaining the circular motion, you will understand what is omega. Omega is 2 pi by t. You are familiar with this or not?
Sir, no, sir.
Omega is the rotation speed. Time is 365 days. Clear?
Yes, sir.
Revolution, I am calculating the revolution speed. I don't know you are familiar or not, but I'm telling like you will understand later. Simply this omega tells us the rotational speed of the any object. At what speed it. For this earth, this denominator is very, very high. There, so this omega is negligible. Very, very small. There, very small.
Okay.
Omega is very small, means so we can consider Earth is absolute, not approximately rest. So Earth is an approximately rest means Earth is an approximately inertial frame by an experiment. but actually Earth is not fully inertial. It has some omega. There, but by an experiment we can consider, because Earth is moving very slow. It is not moving very fast. Clear? So all the Newton's law, first law, second law, third law is valid in inertial framework. Clear? But there are some frame that is not inertial. Clear? Now what is inertial clear to you? Inertial means
Yes, sir.
simply at rest it should not accelerate. There it should not be accelerating thing. There should not be any acceleration in the frame. There that is inertial. If you ask me like what is how do we decide this frame is inertial or not? There are some points. Just write down. Write down this point. I will write here. Write down. Important note. Write down. If a frame becomes inertial, if a frame become inertial frame, it does not accelerate as seen from the earth. As seen from the earth means ground. There, if a frame becomes inertial frame, if it does not accelerate as seen from the ground. Clear? If it does not accelerate as seen from the ground. If you are looking any frame from the ground, if it is accelerating, then we say it is a non-inertial frame. Clear? Non-inertial frame. Clear? A frame is accelerating as seen from the ground. Say it is non-inertial. Clear? Okay. Meaning is what? Like, have you seen like, for example, I will ask you like one question. Let us suppose there is a moving train, car or train, okay, like this. And this car is inside the car. There is one driver. Clear? And in this driver, so I think I will explain again. Is my screen visible to you? Because of some network issue, okay? It's happened. For example, this car, inside this car, this driver is there, okay, driving. He is driving the car, and this car is moving initially with 4 meter per second. Okay? After some time, this car has velocity. This velocity of the car continuously increasing, 10 meter per second. Okay? And if you are on the ground, if you are the observer, then you are on the ground. You are on the ground. Clear? Ground is what? Inertial frame. Clear? Inertial frame. And if you are looking this car, if you are looking this car is in acceleration. You can check. This car initial velocity is 4, then it is moving with 10 meter per second. So we can say, what we can say? This is non-inertial. Clear? Understood? The moving car is non-inertial. The car in which a driver is sitting, that frame is non-inertial. Understood, Dinesh? Clear? Any doubt? Hello, Dinesh. Is it clear?
Sir, yes, sir. Clear, sir.
Okay. Now moving to the next non-inertial frame. Clear? See, we know that if I ask you one question, okay, I will ask question, okay. So I ask a question to you. There is a mass attached with a string like this. This mass is m. Okay. And if I ask you one question, find the tension force. Clear? If you are the
Okay.
observer on the ground, okay? If you are the observer on the ground, then you will say, sir, this is my system. Here, weight is mg,
The tension will
tension
be
is.
acting upward.
Then you will say, sir, t minus mg, but this is not accelerating. Its acceleration is 0. You say t is equal to. Clear? This is the right answer. Okay?
Okay.
You will
Okay,
say
sir.
like this. But if I ask you one more question, if I ask you one more question. This is the lift. Clear? And in this lift, from a string, there is one mass is attached. Okay?
Okay, sir.
So, for example, inside the lift, one observer is there. Clear? This observer,
Okay.
C. And one observer is on the ground. Clear?
Yes, sir.
This observer is A. If I ask you, Dinesh, according to A, and this lift is moving with A naught acceleration up. Clear?
Yes, sir.
If I ask like, as per A, I want to know what is the tension in the string. So I draw the free body diagram of this block. It is mg, one tension. Clear?
Okay.
The net force in y direction, because it is moving in y, equal mass of system to acceleration. That is A. Since this lift is moving with A naught acceleration up, then according to A, this mass is also moving with A naught acceleration. Clear?
Yes, sir.
Clear? The net force in y direction is P up, mg down. Here, tension comes out to be mg plus A naught according to A. This is the right answer because A is in inertial flow. Clear? This is
Okay.
as per A according to A. But if I ask, next question, if I ask you, like according to C, what is the answer? Clear? According to C, if I draw the free body diagram, mg is down, clear? Tension is up. If I write the equation E minus mg equal mass into acceleration of this, like this system, clear? What is the acceleration?
Okay,
Tell
sir.
me. 0. According to C, because both are in the same lift. Clear? If you are in the lift and you are looking the objects nearby you, then it is at rest. Clear?
Okay, sir.
Because now you are where? Why? Now you are saying like this, T equal mg. You are applying Newton's law and give me the answer T is equal to mg. Here, then my question is, who is right? Who is right? Only person A is right.
Both.
Why? No, he is also right, but he is doing wrong thing. Why? What he is doing wrong thing? He is applying since person C frame is this moving lift. Where they are located, moving lift. Clear? So for person
Yes, sir.
C, their frame is accelerating frame because it is moving with A naught acceleration up. There, it is an
Okay.
accelerating frame. So if they apply the Newton's law, that is not valid. But still they are applying, so that is wrong. Clear? So
Okay. So
Newton's
can you
law,
please repeat it again?
I'm saying like person C, for person C, if their frame is lift, moving lift, this lift. Clear?
Okay, sir.
According to A, because if you look at from the inertial frame, C is moving up with a naught acceleration. Clear? Its velocity continuously increasing. Okay.
Okay,
So
sir.
person observer C frame is lift. It is moving frame, or we can say accelerating frame or non-inertial frame. Then in that frame he is applying the Newton's law. That is not valid at all. Okay.
Okay, sir.
Newton's law
Okay,
is
sir.
valid only in inertial frame. So according to A, tension equal mg plus a naught, but according to C, tension is mg. So C is wrong. Clear? Then my question is how to apply Newton's law in non-inertial frame. How to apply? So one trick I am telling, like this is simply correction. I will tell you correction. Okay. What is the
Okay, sir.
correction? Correction is, what correction is missing? Can check. If I need C is equal to mg plus a naught. Clear? So what he should do? Mg, clear? He is up. If he is applying m to a naught down, clear? Then he will say t minus, because m a naught niche, mg equal, clear, 0. Then he will get the answer equal mg plus a naught. What is m a naught? I will tell. This is a missing factor, na m a naught. Clear?
Oh, yes, sir.
This is the missing factor. This is a missing factor or correction factor. This correction factor is pseudo force. Pseudo imaginary force you are seeing, but actually pseudo force does not exist. Clear? So if you are, so what is this? E is equal to mg plus a naught. So pseudo force is nothing. It is a correction factor, or you can say imaginary force. It is a false force. Clear? Does not exist. Clear? This universe. So pseudo force we are using just to make the Newton's law valid in non-inertial frame. Clear? So pseudo force is what? It. You can write also. If you want to apply pseudo force means simply pseudo. How to apply? Pseudo force formula is its magnitude. Okay, force has direction and magnitude. So what is the magnitude of pseudo force? Magnitude m into, what is m? What is m?
Mass of the object.
M, write down mass of body. M is the mass of body on which Newton's law is going to apply. Mass of body or system on which law is applied. Student,
Sir, which law, sir?
Newton's
Newton's
law.
law.
Yes.
Okay, sir.
What is A? A is the
Acceleration.
acceleration of observer A is the acceleration of observer as seen from the earth. As seen from the earth. Earth means itself or ground. Here,
Okay, sir.
Now, since it's a vector quantity, direction also, what is the direction of pseudo force? Direction. Right on. Opposite to the opposite to the acceleration of observer. Which observer? Observer in the non-inertial frame. Clear?
Okay, sir.
Clear?
Yes, sir.
Now, you check also previously. M is the mass of an object on which law is going to apply. A naught is the acceleration of observer. Okay, see. If it is going up, here A naught is the acceleration of observer that is in the non-inertial frame as seen from the
Okay.
inertial frame. Here, if our observer A is looking C, then according to A, C is moving up with the A naught acceleration. Clear?
Sir, how direction is opposite, sir?
Direction is opposite because it's a correction factor. It is always opposite to the direction of direction opposite to the acceleration of observer. It's a correction factor. Clear? That is why direction is opposite. If
Okay, sir.
observer is going up, pseudo force is down. If observer is going right, pseudo force is left. Clear?
Okay, sir.
For example, I will ask some question to you. See. One question is this is the any car and this car is moving with given acceleration and this is the block having mass. Okay. Okay.
Okay, sir.
If observer is here, is the observer. Clear? Now,
Okay, sir.
first of all, tell me if you are on the ground. Let us suppose this is Dinesh. He is on the ground. Okay. And Dinesh, my question is, according to you, for example, for person B, frame is this frame. Clear?
Okay, sir.
This is one more observer. This is one more observer. Clear?
Okay, sir.
Stood. Observer B. For observer B, frame is frame. Big frame. Clear? For observer
Yes,
A,
sir.
frame is ground. Now you please tell me, the train is inertial frame, non-inertial frame.
Sir, non-inertial, sir.
Yeah, non-inertial. So if I ask you like, what is if I want to apply Newton's law on this, here, law. If I ask you to draw the free body diagram, then how will you draw? One is
Sir,
empty,
one.
one is normal action. Clear?
Okay, sir.
Third is pseudo force. Now pseudo force in which direction? According to B,
In the
okay.
direction.
According frame is going in the right, then pseudo force will be in the left. Clear?
Okay.
Pseudo force magnitude is mass of an object on which law is going to apply, multiply acceleration of observer as seen from the ground. Observer is going given acceleration. This is pseudo force. Clear?
Okay, sir.
Clear? Is it clear to you?
Yes.
Now, if I
Yes, sir.
ask one more question to you, tell me. Let us suppose, same question if I ask, this block is here and it is moving with constant velocity. constant velocity. Train, okay?
Okay, sir.
So I asked, this is an observer, okay? So according to this observer, you need to draw the free body diagram. Can you draw?
Yes, sir.
Please draw. And this is the observer C. So observer A. Please draw the free. According to C, according. Force and laws of motion will take time, okay? Because it's a very big
Okay, sir.
unit. So no need to worry like regarding this. Take time.
So if there is a constant velocity, there will be the acceleration will be zero only, no, sir?
Constant velocity means what? Simply I am telling. This train is non-accelerating. This is inertial frame. Here you can't say it is
Okay,
a
sir.
because it is not accelerating. Acceleration of velocity constant means its acceleration is zero. So if you look at from C, this train is also inertial frame. So you apply it correctly. It is mg or it is as per A, as per B. For both of them, this is a free body type. Because inertial clear.
Okay, sir.
Okay, now tell me one more question. I can right finish. Maybe. Okay. Hmm. So I ask you one more question right now. Let us suppose this is one more train. Yeah,
Okay, sir.
and this train is this is the observer. This train is moving like this, okay? A2 acceleration. And this is the block. Will you please draw the free body diagram of this block as per
Okay, sir.
observer C? Ah, very nice, very nice. So next topic is right now. Next topic is right of conversion of frame. It's the last
Okay.
topic, okay? Then constant
Okay, sir.
relation I will discuss tomorrow. Actually, I'm also biased. Here I'm outside now.
Yes,
Somehow
sir.
I'm taking time for you actually. I always wanted to teach, but I think condition is not fulfilled actually.
No
From
problem,
last
sir.
4 weeks or 1 week around days, I think. I want to arrange internet connection. It's a lot of problem. So somehow I get connection. Be like
Okay,
conversion of frame. Conversion of frame means what? If I ask you, like, if you know the velocity of an object, relative velocity concept we have learned. If you know the velocity of an object with respect to ground, clear? Then if I ask you what is the velocity with respect to another frame, clear? Then how to convert frame, clear? Meaning is what?
okay, sir.
Still from this example. Let us suppose is the velocity of I need to charge actually. Not, not in. Meaning is what? let us suppose velocity of any object, like I say, velocity of velocity of trolley with respect to lift. T is trolley, L is lift. Let us suppose this 6 meter per second. Clear? If
Okay,
I
sir.
are in velocity of lift with respect to ground is 3 meter per second. Clear?
Okay,
If
sir.
I ask what is the velocity of trolley with respect to, then how will you find? Because I'm asking what is the velocity with respect to ground means ground free. You don't know. We know with respect to lift 6 meter. How will you find?
Sir, direction. Sir, the direction of trolley is in the direction of lift or.
Direction is like this. Okay. Okay.
Okay, sir.
So I'm telling this conversion of velocity of trolley with respect to lift. Right leg. T minus V. This T, first T, then L. T. Yeah.
Okay, sir.
Then nothing is given, always take down. Okay. Velocity of trolley with respect to lift is 6 I cap. Clear? Velocity of trolley with respect to ground we need to find. Velocity of lift with respect to ground is 3 I cap. If you find T, 6 plus 3, 9. 9 meter per second, 9 inch.
Okay, sir.
Here is it clear to you?
Yes, sir.
So velocity of trolley with respect to ground is 9 meter per second in I direction. Can you please check, like same trolley with respect to lift is, it is moving is 6 meter per second. There, the same trolley with respect to ground is going with 9 meter per second. This is the variation because of change in the frame. So velocity, acceleration, there they are displacement also, like displacement is ut plus half at square. If acceleration will change, then displacement also change.
Okay,
So
sir. Yes, sir.
is it clear to you?
Yes, sir.
So frame conversion of frame we should learn also. We will enormous use in mechanics conversion of frame, like river water problem there, and
Okay, sir.
similar problem like rain, like umbrella rain problem. Many questions are there. So frame means simply where our observer is located. So observer is swimming in the water, so water is a frame. Yes. If it is
Okay.
written like a swimmer is swimming with a 2 meter per second in water in river, then you can't say this velocity is with respect to the ground. It is with respect to the river because swimmer is in the river. Clear?
Okay, sir.
So if you are in the
Yes, sir.
train, clear? If you are in the train, then and train is moving at 120 km per hour. Clear? If I ask you, let us suppose one question. If I ask last question, okay? This is a moving train. Clear? That's the blue train. This is an observation. This train is moving with 100 km per hour. Okay? And one
Okay,
person
sir.
is on the platform. He is C. There and one more person is here. He is D. If I ask you what is the velocity of A with respect to C, V minus VC, nothing is given, always take down. Clear?
Okay, sir.
Is it clear to you?
Sir, velocity of A with respect to C.
So this is what C means. C is looking A. Means
Okay,
what?
sir.
Velocity of A as seen from C. Or velocity of A with respect to C. So what is the velocity
Okay.
of A with respect to ground? If you look at ground means this C, okay? C observer,
Sir, 100 km/h.
100 I. Velocity of C is on the ground,
Zero.
rest.
Zero.
So what is the velocity of A with respect to C? 100 I.
100 meter/s.
Okay.
Km/h.
Now you just tell me what is the velocity of similar object A with respect to B.
Sir, it will be zero.
100 I. Okay.
Okay.
So frame is clear to you.
Yes, sir.
So frame is very important. If you apply Newton's law, you should be very, very careful regarding frame and sign convention. Okay.
Okay, sir.
So I will stop this lecture. In the next lecture, I will start constraint relation, that is geometric relation. There I will explain like what is visible constraint, what is calculated constraint, like pulley weights problem, pulley block problem. Yeah. Then I will move to the
Okay.
momentum. After completing the momentum, I will move to your friction part. System I will explain. Here, this chapter is enormous, okay? Enormous things
Okay,
are
sir.
there. You will solve many
Sir, can we
problems.
complete this? Sir, can we complete this chapter before September 11?
Before September 11, this chapter, you have
Yes, sir.
exam.
Exam to September 11 is my physics term on exam, sir.
So we can complete. I can't say like we can complete, but I will try like around more than 50, 60, 70%. I will complete.
Okay, sir.
I will try, okay?
Okay, sir.
Because tomorrow lecture I will explain constant or visible, because constant and visible is not a part of your syllabus also, but still I want to try. But no worry, I will start friction, okay?
Sir, you can teach like you plan, sir. No problem, sir.
If you want, because I will start momentum then. System momentum, then I will move to the friction, because constant and relation, that is NEET or JEE syllabus. Clear? I
Sir,
will
you can
explain.
teach as you plan, sir. No problem with that, sir.
So no worry, I will. No. If your exam is on 11, no worry, I will teach it later, okay? No need to worry.
Okay, sir.
Yeah, that we can skip for time being, we can skip. We want our syllabus, that is also important. There, that those
Okay, sir.
topics which are very, very like not in your CBC syllabus, that is constant or visible relation, then we will we will discuss later also. Okay?
Okay, sir. Okay,
Because I
sir.
will give extra time also. This topic
Okay, sir.
actually, no need to worry. After this, tomorrow I will explain system, then momentum. Momentum question will solve. Then after that, I will start friction. Clear?
Okay, sir.
Pulley way, pulley block problem, those problems I will solve it. Okay? No need to.
Okay,
Okay,
sir.
Dinesh, thank you so much. Take care. Thank you so much for your wishes. Take care. God
Thank you,
bless
sir.
you. Bye bye.
Bye. Thank you, sir. Bye, sir.